Welcome back. This is El Sam. Today in our UTME course, we'll be treating progression, the first part. So we've broken it into two parts. So the first part that has to do with arithmetic progression is where we're going to focus on. But we're going to look at all of this. So it's going to be a very interesting class. Now don't forget that my job here is to simplify mathematics for you so that you can use it confidently. So if you have not subscribed to this channel, kindly subscribe now so you can keep getting interesting solutions to mathematical problems. So let's start. Sequence and series. So the first question is, what is a sequence? A sequence is simply an ordered list of numbers. Get the point? An ordered list of numbers or items. Now they follow a regular pattern. Now each of the items, we call them terms. So let me give you an example. Let's say we have 5, 10, 15, 20. You can see the pattern, right? The next will be what? What? So let's go. So what will be the next? Following this pattern, that will be 25, right? And the next will be what? 30. And the next, 35. Okay? So now this is a sequence. So what did I say a sequence is? An ordered list of numbers or items. So this is a sequence. Now when you get the sum of all the terms in a sequence, that is a series. For example, this same sequence, let's add all the terms, it becomes a series. So this is a sequence. Now this is a series out of this same sequence. So we have 5 plus 10 plus 15 plus 20 plus 25 plus 30 plus 35 plus ... Okay, ... Okay? So, hope you get the difference. So in a sequence, you're just having a list, ordered list of numbers. But in a series, you are adding the sequence. So a series is just like an addition or the sum of a sequence. Now, a sequence or a series can be infinite or finite. So I believe you know what that means. If it's infinite, it goes forever, no end. It's finite, it has a number, so you define where it stops. So that's the first part, series and sequence. Now both series and sequence, if you look at it, it's a progression. It's a progression. Now we have two types of progression, or many types of progression, but we're going to focus on two for the purpose of our class. And those two types will be, let me rub the board. So this is series and sequence. Okay, so for types of progression number 2 now, we have, So we'll have progression. So we're going to focus on two types, just two. One is arithmetic progression, and the second is geometric progression. So this one, for short, we're going to call it AP. And for short, we're going to call this one GP. So AP, anywhere you see me writing AP, I mean arithmetic progression. Now this one, when it comes to growth, this one represents linear growth, like increase in salary and things like that. While this one, exponential growth. So if you see a linear sequence or series, you are referring to arithmetic progression. And then for exponential series or sequence, you are talking about a geometric progression. So these are the two types we are going to consider. So for this first part of the lecture, we are going to focus on arithmetic progression. So in the second part of this lecture, or the next lecture, we're going to focus on geometrical progression. So let's begin. So the first question will be, what is an arithmetic progression? What is an arithmetic progression? Okay, so let's look at the same example we used earlier, or let's use a new example. Let's say 3, 6, 9, 12, 15, and so on. Now, if you have a series or sequence, when I say progression now, I'm talking about either a series or a sequence. Now, if you have a progression where the difference between any two consecutive terms is a constant, that kind of progression is defined as arithmetic progression. Get the point. The difference between any two consecutive terms is a constant. Let's look at this. 3 and 6, are they consecutive terms? Yes. So when we say consecutive, the one that follows next, the next term. So in this case, 3 and 6 are consecutive terms. And now what's the difference between 6 and 3? Is 3. 9 and 12 are consecutive terms, right? Good. What is the difference between 9 and 12? 3. 12 and 15 are consecutive terms, right? Because 15 is the next. And what's the difference between 12 and 15? Is 3. Now you see that the 3 is constant. If you go 6 and 9, the difference is 3. So this 3 now is constant. So that difference that is constant, we call it common difference. So get the point. If you have a progression where the difference between any two consecutive terms is constant, that the value is the same throughout, that is an arithmetic progression. So let's look at other examples of arithmetic progression. Let's say 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus ... Now, is this an AP or a GP? Or is it an arithmetic progression? Let's leave the other types. Is this an arithmetic progression? How do we know? We'll just check. Pick two consecutive terms, get the difference. 3 minus 1 is 2. 7 minus 5 is 2. 11 minus 9 is 2. 5 minus 3 is 2. So this is an arithmetic progression. So that's how you know whether or not the series or sequence is an arithmetic progression or not. Okay, so I will give you 3 series or sequence now. You're going to tell me whether or not they are arithmetic progression. So a quick walk there. So state whether or not these are arithmetic progression. So you are telling me that it is or it isn't. Okay, so state whether or not each of the following is arithmetic progression. So they're going to tell me whether it's an arithmetic progression or not. So the first one, 2, 4, 6, 8, 10. Second one, 25, 31, 37, 43. Third one, 1, 2. So this is a quick classwork for you, but drop the answer in the comment section. So you want to tell me whether or not it is an AP. So you can just say number 1, AP, or number 1, not AP. Remember, AP stands for arithmetic progression. So for number 2, tell me whether it's an AP or it's not an AP. And number 3 also, tell me whether or not it's an arithmetic progression. So now Now that we know what an arithmetic progression is, we can now look at how to solve problems on AP. But let's understand the concept of common difference very well, and then we'll proceed. Please, I'm waiting for your answer in the comment section. Okay, now common difference D is that constant that you get when you subtract two consecutive terms. So, as the name implies, it is the common difference. So, it's common to all the consecutive terms. Okay? So, now how do you calculate common difference? Let's say we have 4, 9, 14, 19, and so on. Now, is this an AP? Yes, because 9 minus 4 is 5. 14 minus 9 is 5. 19 minus 14 is 5. So our common difference is the second term minus the first term. The same common difference, it is the third term minus the second term. That's our common difference. So if you check the answer for this, the answer is 5. Check the answer to this, it's also 5, right? So we'll call it the common difference. So the general formula is that common difference, which we're going to be calling D, D is equal to Tn minus Tn minus 1. So D, if n is 10, this will be T, n is 10, n minus 1 will be 9. So just the terms must be consecutive. So this is our standard formula for common difference. Now, because of some problems we're going to solve later in the course, note that T2 minus T1 is the common difference. The value is the same as T3 minus T2. This is also the common difference. So just save this somewhere in your memory. We're going to need it when we start solving exam-style questions. So T2 minus T1, just like what we got from here, is the common difference, and it's equal to T3 minus T2, and so on. So it goes like that. So we might need this somewhere when we start solving questions. So we've looked at common difference. Now let's look at the business of the day. Nth term of an AP. TH, nth term of an AP. Okay? So let's say we're given an AP, say let me give you the AP. Let's use that same example: 5, 10, 15, 20, 25, and so on. Now, the first term, the term 1, we're going to call it A. The first term, we're going to call it A, and in this case, the value of that is 5. So A represents the first term, and in this case, the value is 5. And the second term will now be A plus D. This is strictly for arithmetic progression. So the second term will be the A, the first term, plus the common difference. And let's look for our common difference in this case. Our common difference will be what? Is T2 minus T1, right? Which is 10 minus 5, which is 5. So our D is 5. In this case, so that will now be what? Our A is 5, plus our D is also 5, making 10. Check it. The second term, T2, is 10, and it's 10. The third term is A plus 2D. That's, you add difference, you add the difference again. That will be what? A is 5 plus 2 times. Our common difference is also 5. So this will give us 5 plus 2 times 5 is 10, making 15. And that's the third term, 15. Now, this gives rise to the general formula for nth term of an AP. So the nth term of an AP equals to the first term A plus the number minus 1 D. But relax, I'll explain all the terms in this formula. So the formula says the nth term of an AP is defined as the first term plus the number minus 1 multiplied by the common difference. So just save it in your memory. Tn equals to A plus n minus 1 D. So this n is this n. So to make our work easy, T10 will be A plus 10, right? So 10 minus 1 will be 9, right? 9D. T7 will be what? A plus 6D. So A plus 6D. So just subtract 1 from the number. T10 will be 9D. Tn will be n minus 1D. Okay? So let me define the terms in this formula. I need to put it where we remember. Let me put it here so that I can rub this side. So Tn is A plus n minus 1D. Let me put it here so that I will not have to rub it. Okay, so now that we have our formula, let me define all the terms in this formula so that it's easier for us to work. So this A first, as I've said earlier, A is the first term. So I explained that earlier. Now n is the number of terms. So the number of terms in that we are considering, that is the n. So that will be given to you. Now D is obviously the common difference. So we have looked at D, N, and A. So it remains Tn. So Tn now is the nth term or the last term. So Tn is the nth term or the last term. Now this is how the questions will be presented. Let's do a few examples. Let's say example 1. Find the sixth term of the sequence 1, 3, 5, 7, and so on. Now, solution. Now, when you are given a problem like this, you just get all these terms available. Since we are looking for the nth term or the sixth term, our first term is 1, obviously. Our common difference is T2 minus T1, right? Remember, we've established this earlier. So 3 minus 1 is 2. Now, the number of terms in question here is 6 because we're looking for the sixth term. So we have first term, second, third, fourth, and so on to 6. So what we're looking for is the sixth term. Now remember what we said earlier. T6 is equal to A plus 5D, right? 6 minus 1, that's 6 minus 1 here. So that will simply be A, which is 1, plus 5 multiplied by the common difference, which is 2. Our common difference is 2. So, and that will give us 11. So the sixth term of this progression is 11. And let's even try it. 1, 3, 5, 7, 9, 11. So 1, 2, 3, 4, 5, 6. So the sixth term is even 11. But now, what about the, let's say, 30th term? Let's say find the 30th term. So you can't just keep counting. So the 30th term, T30, will be A plus 29D, right? Or we don't even need this bracket. A plus 29D. It's clear enough, right? That's 29D. So that will be A. What's our A? So since we're treating the same sequence, our A is T1 plus 29 multiplied by D. What's our D? Our common difference? It is 2. So this will be 1 plus 29 multiplied by 2. That will be 58. So our answer is 59. So if you continue like that to the 30th term, you will get 59. So it's actually interesting. All your focus should be is on your A and your D. Once you have your A and your D, the n will be given to you as what you're looking for. You can always get your nth term. So this is how we get the nth term of an arithmetic progression. So let's see a tougher example. So this example 1, let's go deeper. Yeah, so they will not make everything straightforward like this, obviously. So let's start doing that from here. So example 2, the first term of an AP is 3 and the fourth term is, let's say, 12. Find the first, no, sorry. Let us go straight. Find the 10th term. So this one says the first term of an AP is 3 and the fourth term is 12. Find the 10th term. So solution. So the first term, A, as we've already established, is 3 according to the question. And they gave us the fourth term, T4. The fourth term is 12. Now we're to find the 10th term, T10, is what we don't know. But now if you pick this fourth term T4 normally is what? A plus 3D, right? The fourth term, A plus 3D, equal to 12. According to this, which came from the question, that the fourth term is 12. So the T4, which is A plus 3D, is equal to 12. But now we already have A as 3, right? So if we bring it here, so 3 plus 3D equal to 12. Let's collect like terms. So 3D equals to 12 minus 3. So 3D equal to 9. And if we divide both sides by 3, our D equal to 3. So now we have A and we have D, so we can find anything. Now it says find the 10th term. So T10, as we all know, is A plus 9D. So we have our A and we have our D. So our A is 3 plus 9 multiplied by our D, which is also 3. Okay, so this gives us 3 plus 9 multiplied by 3 is 27. So 27 plus 3, that's 30. Okay, so that's the kind of how you will be examined in UTME. But let's just take it a step higher again. So that we'll get the picture clearer before we move to exam style question. And hope I'm not too fast. I'm just trying to keep the videos shorter. Okay, so let's look at an example 3. Okay. Okay. And the question says the second term of an AP is 5. And the fifth term is 17. So no first term, no common difference in this one. The question says find the sum of the first term and let me add a D here. So English does not become our problem. Find the sum of the first term and the 12th term. Okay? Now look at this case. We are not giving first term. We are not giving common difference. So what do we do? Now let's start with what we have. First, they gave us the second term, which is T2. And the answer is 5. They also give us the fifth term, which is T5. And the answer is 17. Okay, so now from here, this is enough information to work with. Now, T2 is A plus 1D. Remember, Tn is A plus the number minus 1. So T10, remember I said it's A plus 9D. Just subtract 1. So T2 will be A plus 1, 2 minus 1, 1D. Right? So A plus 1D equal to 5. Let's call this equation 1. And T5, that will be A plus 4D, right? And it's equal to 17, equation 2. So if you look at this, A, D, constant. So we can just simply say equation 2 minus equation 1. That will just solve the problem. Equation 2 minus equation 1. So A minus A, 0. 4D minus 1D, that's 3D, equal to 17 minus 5, that's 12. That's equation 2 minus equation 1. So A minus A, 0. 4D minus 1D, that's 3D. 17 minus 5, that's 12. So that's how we got D. So from here, we can find our D easily. So we can just divide both sides by 3, and we easily get our D. So this cancels this. Our D equals to 4. Now we can substitute this 4 for D in either in this equation 1. Let's use the easier equation. So we can say, okay, let me come down here. Substitute 4 for D in equation 1. So in this equation 1, now anywhere we see D, we put 4. So let's bring it. What we have is A plus D equal to 5. So A plus D is 4 equal to 5. Hope this is still obvious. Right? So A plus D equal to 5. So from here, A will be 5 minus 4, which is equal to 1. So now we know our A as 1 and our D as 4. So these are the things that we need to solve any problem. Okay? So the question says find the sum of the first term and the 12th term. So we know the first term already. First term, which is A, the answer is 1. Now, the 12th term, remember T12 will be A plus 11D. This is already established. So our A is 1 plus 11 multiplied by our common difference is 4. So we have 1 plus 44. 4 times 11 is 44. And our answer is 45. So, but that is not what is asked of us. What they want is the sum of the first term and the 12th term. So our sum will be T1 plus T12. So our first term, T1 is 1. our first term, which is a, is 1, plus our 12th term is 45. And then our answer is 46. Okay, so we've looked at series and sequence, types of progression, arithmetic progression, common difference, nth term of an AP. So one more term to look at, and then we'll start solving exam style questions. So this one you have to be very focused. So sum of n terms of an AP. Okay, so sum of n terms of an AP. Now imagine that you have an AP. Okay, let me put it up here. Sum of n terms. Now watch, there's no th, it's just, it ends with s, n terms. The former one was nth term, th, but this one is n terms, s. So sum of n terms of an AP. Okay, now the formula, let me just go straight. The formula Sn equals to n over 2 into 2a plus n minus 1d. So this is the formula to find the sum of n terms of an AP. You can also use this formula, n over 2 into a plus l. Okay, now everything you know, n is the same n number of terms, a is the same a first term, d is the same d common difference. Now this l is the last term, but you only use this formula when you are given specifically the last term. So if you are given the last term in the question and are required to find the sum, that's where you use this second formula. Otherwise, this is the formula you would use. Okay, so remember that Sn is the sum of n terms. A is the first, okay, we know A already. A is the first term. N is the number of terms which you will be told, and D is our common difference. Okay, as we round up, let's see how this works. So I'll leave the formula up here. I'll put 1 or 2 questions and we'll solve together. So just jot down these formulas. Remember, this one is the main formula. This one, you use this one only where you are given the last term. Okay, now let's say we have this. I don't know what example is this. This should be example. Is it 5 or 6 or 7? Whatever example. Let's call it a question. Let's use that first example. Let's say 5 plus 10 plus 15 plus 20 plus. So this is an AP, obviously. And this is a series, right? Now they say find the sum of the first, this 1, 2, 3, 4, right? Let's say the first 8 terms. Now you literally need the sum. If you add all the terms together, that's what we're looking for, the sum. So you are adding all the terms together. So if you look at this, let's see how we apply this formula now. Our first term, our A, which our first term, based on what we have here, is 5. Our common difference is T2 minus T1, right? 10 minus 5, 5, or 15 minus 10 is 5. So our D is obviously 5. Now our N will be what? Since we're looking for the sum of the first 8 terms, our N is going to be 8. And if we bring this to this formula, we're looking for the sum now. S8, sum of the first 8 terms, will be 8 over 2, or let me write it, okay. 8 over 2, that's N over 2, into 2A. 2 multiplied by A, and our A is 5. 2A plus N minus 1. Our N is 8, so 8 minus 1 is 7, multiplied by our common difference, which is 5. Okay, let me use this kind of brackets. Okay, so this is our formula. S8 is n over 2, 8 over 2 into 2 multiplied by a, that's 2 multiplied by, okay, let me use multiplied by since there's no x there. So 2 multiplied by 5 plus n minus 1. This n minus 1, since our n is 8, 8 minus 1 is 7 multiplied by d, which is 5. So this will give us 4, that's 8 over 2 is 4, multiplied by, you have 10 plus 35. So we have 4 multiplied by 35 plus 10, that's 45. That's 35 plus 10 is 45. So 45 multiplied by 4. 4 multiplied by 5 is 20, write down 0, carry 2. 4 multiplied by 4 is 16 plus 2, 18. And then your answer is 180. So what it's saying is that if you add, let's say you go 5, 10, 15, 20, 25, 30, until you get to the 8th term. If you add them together, you are going to get 180. Let's see another example. Another question says find the sum of the first 50 odd numbers. Find the sum of the first 50 odd numbers. So if you pick the first 50 odd numbers, the sum of all of them, what is it? So that's what the question asks us to find. So our odd numbers are 1, 3, 5, 7, and so on, right? So based on this, our first term is obvious, 1. Our common difference is 2. That's 7 minus 5 is 2. 5 minus 3 is 2. 3 minus 1 is 2. So our common difference is 2. Now our n will be what? Based on the question, 50. Because we have to find the sum of the first 50 odd numbers. So our S50, based on what we have here, will be 50 over 2, that's n over 2, into 2 multiplied by a, which is 1, that's 2a, plus 50 minus 1, that's 49, multiplied by our d, common difference is 2. So you have 50 over 2 is 25, multiplied by 2 multiplied by 1 is 2, plus 49 multiplied by 2, that's 98. So what we'll have is 25 multiplied by 100, and that will be 2500. So if we add the first 50 odd numbers, what we'll get is 2500 or 2500. Okay? So we've taken time to look at arithmetic progression, a lot of it. Now, we're going to put in exam-style questions that we'll solve so that we'll see how solid we are in this topic. But before that, let's look at a few properties of AP so that we'll round up. So 1, if you have A, B, C, that's if A, B, C are in arithmetic progression, then 2B equals to A plus C. That's, let's say 5 plus 10 plus 15. These 3, they are in AP, right? So 2 multiplied by this B, 10, is equal to 5. That's A plus C. That's 2B equals to A plus C. So 2 multiplied by 10 is 20, equals to 5 plus 15 is 20. So that's one thing we should know. And this B now is called the arithmetic mean. But the UTME doesn't stress that much, so that's that. Just know that. Now the common difference is Tn minus Tn minus 1. So that's clear. Now D, which is the common difference, can be positive, it can be negative, and it can be 0. So the common difference can be positive, can be negative, can be 0. Now if it is 0, what do you think that means? That's just like you have 10 plus 0, 10, 10, 10. So you have a uniform series, everything the same. Okay. Now the last one says the sum of n terms of an AP. Okay, the sum of arithmetic progression terms, as all the terms in an AP, is always a quadratic function of n. That's a big one. Can we still solve one more problem? Okay, good. Now let me give you this formula. I want to emphasize on this last point made based on this formula, that the sum is always a quadratic function of n. Now you may have seen this question, and let me ask it, but let me bring it down here since we're rounding up. So I want to make n the subject of this formula. So our formula is Sn equals to n over 2 into 2a plus n minus 1d. Let me use this kind of brackets. So let's make this n the subject. Make n the subject. So for the sake of, to avoid confusion, I will remove the n from here just to avoid confusion, but we know that the s stands for the sum of n terms, right? Okay, so what we have is s equals to n into 2a plus n minus 1d all over 2. This n over 2, I'm just bringing it this way so you can follow easily. So I want to cross multiply. So from here, 2s equal to 1 multiplied by n into 2a plus n minus 1d. I'm just trying to be fast. Okay? So if we multiply this, we'll have 2s equals to 2an, that's 2a multiplied by this n, that's 2an, plus n multiplied by d, let's call it dn into n minus 1. That's n multiplied by d, which also multiplied by n minus 1. So it's dn multiplied by n minus 1. So let's expand this bracket so we'll have everything linear. So 2s equals to 2an plus dn squared, that's dn squared minus dn. Okay? So from here, remember we're trying to make n the subject, n. Okay? So let me arrange this way. So dn squared, that's this dn squared now, dn squared plus 2an, that's dn squared plus this 2an minus this dn, let's bring this one this way, equals to 2s. I just rearranged. So dn squared, that's this, plus 2an minus dn equals to 2s. So I want to bring the 2s inside, so we have our plain quadratic equation. So from here, dn squared plus 2an minus dn minus 2s equal to 0. Good. So from here, if we collect n is common here, so this will give us dn squared plus 2a plus d into n, that's n multiplied by d, that's this dn. Sorry, this is minus. Now n multiplied by 2a, that's 2an, right? Minus 2s equal to 0. Now if you look at this very well, you will see a clear quadratic equation in n. Let me bring it up here. So like I said, you will see a clear quadratic equation in n. So let me make it obvious. So what we have is dn squared plus 2a minus dn minus 2s equal to 0. Good. So our a, if you remember, our ax squared plus bx plus c equals 0. That's standard quadratic equation. Our x now being our n, so means our a in this case is going to be d. Our b, the coefficient of x as coefficient of n, will be 2a minus d. and our C will be minus 2S. So that's A, B, C. And remember, for this, you use this formula generally, that X equals to minus B plus or minus the square root of B squared minus 4AC all over 2A, right? That means our N will be minus B. Our B is what? 2A minus D. That's minus B plus or minus the square root of B squared. What's our B? We still have this as our B. That's 2A minus D. That's B squared minus 4 multiplied by A. Our A is D now. 4 multiplied by D multiplied by 4AC. That's 4AC. 4AC. And our C is minus 2S all over 2A. All over 2A. So our A in this case is D. Okay? So our N equals to minus 2A plus D. That's minus 2A. Minus gives us plus D. Plus or minus, now the square root of, if we expand this bracket here, remember how to square a binomial, we'll have 4A squared minus 4AD plus D squared. That's, I've expanded this bracket now. Now minus and minus will give us plus. If we multiply all of this, we'll have 8. 4 multiplied by 2 is 8 ds all over 2d. All right, so we can keep simplifying further. You can simplify further till you get an answer. Remember, if it's an exam, you're going to simplify until you get an answer in the options. So this is one way to go about it. You may not bother much over this because I just wanted to show you that it is like the n is a quadratic function. Okay, so now it's time for us to solve exam style questions. So we'll list the questions now and then we'll solve together. So now let's solve problems. So the first question says, given that 443 is the nth term of the arithmetic progression, that's AP, 5, 8, 11, and so on, find n. So the nth term is 443. Now remember, we have given 5, 8, 11, and so on, right? So our first term here will be 5. Our common difference, remember, the common difference is T2 minus T1, right? T2 minus T1, which is 8 minus 5, which is 3. Because I've been told it's an AP already, we don't need to bother. Once it's an AP, T2 minus T1 makes your common difference. Okay, so n is what we're looking for now. We don't know what n is, but the nth term is 443. So remember that Tn equals to A plus n minus 1d. Remember this formula for nth term. So Tn, the nth term, 443, right, equals to A, first term is 5, plus n minus 1. Our common difference is 3. So from here, 443 equals to 5 plus 3 times this n, that's 3n, minus 3 times 1 is 3. So from here we have 443 equal to 5 minus 3, that's 2, plus 3n. That's this 5 minus this 3 like terms, that's 2 plus 3n. So 441 equals to 3n. I believe you know what I did. I took this 2 this way, so 443 minus 2, that's 441. So from here we can divide both sides by 3. So 3 cancels 3, so that's n equals to 3 and 4, that's 1. Remember 1. 3 and 14. 3 times 4, 12. Remember 2. 3 and 21, 7. So our n is 1, 4, 7. So our correct answer will be option B, 147. Okay, so that's it. Now let's see number 2. Number 2 says, find the first term of the sequence x plus 1, 3x minus 18, 2x minus 1, and so on, if this sequence is an AP. I believe we'll know what an AP is. Now, in an AP, you have a common difference. And that common difference is T2 minus T1, which is the same as T3 minus T2, and so on for an AP. So to solve number 2, we are given this sequence x plus 1, that's one term, another term 3x minus 18, then another term 2x minus 1. Now, if these 3 terms are in arithmetic progression, as the question says, it means that the common difference of, remember this is our T1, T2, and T3, at least 3 consecutive terms in that AP, right? So our common difference, T2 minus T1, that's T2 minus T1, will be the same as the common difference of T3 minus T2. So T2, which is 3x minus 18, minus T1, which is x plus 1, that's T2 minus T1, equal to T3 minus T2. So let's do that. That T3 is, 2x minus 1 minus, that's T3 minus T2, which is 3x minus 18. So let's expand. So this will give us 3x minus 18 minus x minus 1. That's minus x and minus 1 equals to 2x minus 1 minus 3x minus give us plus 18. So 3x minus 1x, that's 2x, minus 18 minus 1, that's minus 19, equal to, 2x minus 3x, that's minus 1x, that's 2 minus 3 is minus 1, right, on x. So then we'll have minus 1 plus 18, that will be plus 17. That's minus 1 plus 18, that's 17. Okay? So 2x, this minus 1x comes here, becomes plus 1x, equal to, we'll have 17. This minus 19 becomes plus 19. So 3x equal to 36. So if we divide both sides by 3, our x equal to 12. So 3 times 12 is 36. So that will be our answer. Oh, sorry, that will be the value of x. But now the question says, find the first term of the sequence. So the first term is x plus 1, right? So the first term is x plus 1. The second term is 3x minus 18 and so on. So the first term, x plus 1, is what we are interested in. And since our x is 12 by calculation, if you choose 12 here, you will be wrong. Our first term is x plus 1, so which is our 12 plus 1, and the correct answer will be 13. So for number 2, our correct answer is option B. Let's proceed. For number 3, let me rub the board before. Okay, so let's analyze number 3. The question says, the fourth term of an AP is 13. That's the fourth term. While the 10th term is 31. So let's put it together. The fourth term, T4, is 13. And the 10th term is 31. So T10, the answer is 31. Now, since we are treating AP, we know we can interpret T4 and T10. So T4 can be interpreted as A plus 3D equal to 13. We'll call that equation 1. I already explained that earlier. So for T10, that will be A plus 9D. The answer is 31. Let's call this one equation 2. Now, we can simply say equation 2 minus equation 1. We did this kind of example earlier. So A minus A is 0. 9D minus 3D, that's 6D, equal to 31 minus 13, that's 18. So if we divide both sides by 6, 6 cancels 6, our D is 3. Our D is 3. Now we can substitute this, or we can replace, substitute 3 for D in equation 1 or 2, but let's choose equation 1. So if we bring this equation 1 that says A plus 3D equal to 13, and our D is 3, so A plus 3 times D is 3 again, equal to 13. So A plus 3 times 3 is 9, equal to 13. A is equal to 4, because 4 plus 9 is 13, or 13, take 9 that way, 13 minus 9 is 4. So our A is 4, our D is 3. Now, but the question says, find the 21st term. So T21. So T21 will be A plus 20D. So T21 is A plus 20D, n minus 1, remember. So our A is 4 plus 20 multiplied by D, 3. So that will give us 4 plus 20 multiplied by 3 is 60. And our answer is 64. So the correct answer for question 3 is 64. And that will be option C. And let's come to number 4. For number 4, the question says, the sum of the first 20 terms of the AP that has log A square, log A cube, and so on is dash. So we have to find the sum of... Okay, sorry, I'm jumping to number 5. Okay, let me do number 5. I'll come back to 4. So it says the sum of the first 20 terms of the AP log A square, log A cube, and so on is dash. So let's find the sum of the first 20 terms. Okay? Yeah. So our AP has log A square, log A cube. Now we've learned the laws of logarithms, and they can be of help here. Now this can be written as log A, this can be written as 2 log A, and this can be written as 3 log A. That's 2 log A. Remember, this one can come down. This one also can be brought down this way. So log A, 2 log A, 3 log A. Okay, and so on. Now because we've been told that it's an AP, the common difference is T2 minus T1. So our A as first term is log A. That's obvious. Our common difference, which is T2 minus T1, will now be T2. That's 2 log A minus T1 log A. So 2 log A minus log A, the answer is log A. Just like 2 pencils minus 1 pencil, the answer is 1 pencil. So 2 log A minus 1 log A, the answer is 1 log A. So we know our A and our D now as log A also. Now the question says we should find the sum of the first 20 terms. Remember, sum of n terms of an AP, I gave you the formula earlier. Sn equals to n over 2 into 2a plus n minus 1 d, right? So our n is 20. So S20 will be 20 over 2, or let me just go one more step. 20 over 2 into 2 times A. Our A is log A. That's 2A. That's 2 times log A. Plus 20 minus 1, that's 19 times our D is also log A. Right? So what we'll have is 10 multiplied by 2 log A plus 19 log A, just like 2 pencils plus 19 pencils, that would be 21 pencils, right? So 2 log A plus 19 log A, that would be 21 log A. If we multiply these two, we're going to have 210 log A. That's 21 times 10, that's 210 log A. I remember our laws of logarithm, what we applied earlier. If you have this coefficient, you can bring it to the power. So this can be written also as log A raised to power 210. So these two are equivalent, and that's our answer. Okay? So the correct answer will be option log A raised to power 20, A raised to power 21, A raised to power 210. So this is the correct answer. So A raised to power 210 is our answer, option C. Okay, so the number 4 that I skipped earlier, I would do it, and then I'll allow you to do number 6. I'm waiting for your answer to number 6 in the comment section. So just calm down, relax. Let me do number 4, and then you do number 6. Okay, so for number 4, the question says, okay, for number 4, the question says, an AP has first term 11 and fourth term 32. So clear instructions. So for that AP number 4 now, the first term A is 11, first term 11, and the fourth term 32. So T4 equals to 32. So before we even do anything, let's get our A and D. So T4 is 32. Remember, T4 is A plus 3D equals to 32. But fortunately, we are given A, so we'll bring our A down here. So 11 plus 3D equal to 32. From here, 3D equals to 32 minus 11, that will be 21. So take 11 this way. So if we divide both sides by 3, our D equal to 7. Okay, so now that we know A and D, we can find anything. So the question says, the sum of the first 9 terms. So sum of the first 9 terms. S9, or do I just write the formula? Let me write. Sn equals to n over 2 into 2a plus n minus 1d. Okay, this is the general formula. So our S9 in this case will be 9 over 2 into 2 times a. We have a already. That's 2 times 11. That's 2a. 2 times 11 plus n minus 1. Since our n is 9, 9 minus 1 is 8 multiplied by our d is 7. So we'll have 9 divided by 2 multiplied by 2 times 11, that's 22 plus, okay, let's put this in a bracket. So 22 plus 8 times 7, that's 56. So what we'll have is 9 divided by 2 multiplied by, this will now be 68. Sorry, 78. That's 56 plus 22, that will be 78. Remember, over 1. 2 here, 1, 2 in 7, 8. 2 in 7, that's 2 in, okay, that will be 3, 6 remainder. Okay, let me put it this way. 2 in 78, 2 times 3 is 6. Remainder 1, 2 in 18, 9. So we'll have our 9 multiplied by 39 left. So 9 multiplied by 9 is 81. Write down 1, carry 8. 9 multiplied by 3 is 27. 27 plus 8, that's 35. Okay, it means our answer will be 351, and that will be option A. Okay, so for this number 6 that you are going to solve by yourself, let me give you a hint. This number 6, what you are doing here is not far from what we did in number 2. Now remember, in number 2 we have 3 consecutive terms, right? Now you have 3 consecutive terms: p plus 1, 2p minus 10, and 1 minus 4p squared. So there are 3 consecutive terms of an AP. It says find the possible values of p. So you are just to find p. So remember, t2 minus t1, which is the common difference, is the same as t3 minus t2, which is also the common difference. So if you solve that equation, just go down, you get an answer. All right, so that will mark the end of this interesting lecture. We'll continue with geometrical progression in the next lecture. So I remain Elsam. Kindly subscribe to this channel to keep getting interesting solutions to mathematical problems.